Hello viewer, welcome to our chemistry lesson, and we like to continue in our lessons. But amidst this coronavirus pandemic, we would like to remind you that continue staying at home, continue obeying the guidelines given by our government, that we are going to be safe by now. I hope you are going to tell your friend that we have lessons in chemistry. We are going on in our YouTube channel called Mwalimu Sintonic. Thank you and welcome to our lessons. And, in this lesson, we are going to look at what we call electrolysis or electrolytic cell. Electrolysis or electrolytic cell. So now, what is this? What we are going to learn here? So in our objectives, the learner should be able to, number one, we are saying define the terms electrolysis and electrolyte. Now, number two, we are saying that the learner should describe the preferential discharge and the ions, and then we have those factors affecting discharge. So we have factors affecting discharge. So right away, if you have now identified the objectives here, let us look at now this electrolysis as the last component of electrochemistry. Last component of electrochemistry. We are now seeing that we have finished electrochemical cell. Now we are going to electrolysis. So let's look at this. What is electrolysis? Electrolysis, in a simple definition, is actually the composition of a compound by an electric current. It's actually a decomposition of a compound by an electric current. Now, we are saying a compound that is actually decomposed by electric current is called an electrolyte. We should actually highlight that it's actually an electrolyte, not any other compound, an electrolyte. Then what is this electrolyte that we are talking about here? So we are saying some electrolytes are weak and others actually are strong. So we are going to see strong electrolytes are those that are fully ionized into many ions. The common ones are actually, we have include the following. We have the mineral acids. So when you talk about mineral acids here, we are talking about the three acids. We are talking about sulfuric acid, hydrochloric acid, and nitric acid. Those are what we call the mineral acid. And therefore, these actually are what we call the strong electrolytes. Number two, we have all strong alkalis, like sodium hydroxide and potassium hydroxide. Those are strong alkalis. And then we have all soluble salts. All soluble salts. Remember the word all soluble salt. We have salts which are not insoluble, and we have those which are soluble. Up in Form 2, you learn about soluble salts and insoluble salts. Now, so all of these actually are strong electrolytes. Now, on the other hand, we have weak electrolytes, and there are those which are actually partially ionized, because if the other one was actually fully ionized, it's actually partial ionization. Therefore, we are saying common weak electrolytes include, now we have all organic acids, and organic acids, like for example, ethanoic acid, sulfuric acid, and all that. Organic acids are the ones which are actually weak electrolytes. And then we have all bases except sodium hydroxide. Then we have potassium hydroxide. So these are all bases. Then we have water. We have water as another one, which is actually a weak electrolyte. Now, a compound that is not decomposed by an electric current is called non-electrolyte. But a compound which is decomposed by electric current is called what? An electrolyte. Now, the common electrolytes here include, we have most organic solvents. Let's talk about the petrol, we have paraffin, benzene, methyl benzene, we have ethanol, and not ethanol, but ethanol is actually an organic solvent. Now, so we have here all hydrocarbons like alkanes, alkenes, and alkynes. So we have alkanes, alkenes, and alkynes are the ones which are non-electrolytes. We have also chemicals of life, like for some proteins. We have carbohydrates, we have lipids, starch, and sugar. So these are actually non-electrolytes. They don't have actually mobile ions. Now, an electrolyte is a solid that have a fused ions and therefore do not actually conduct electricity, but the ions are free and mobile in a molten or an aqueous solution and dissolve actually in water state or dissolve in water state. Now we are saying during electrolysis the free ions are attracted to the electrons. The free ions are attracted to the electrons. So you must actually understand this, that the ions here are attracted to the electrodes. The electrons. Which electrodes? We have the positive electrode, then we have the negative electrode. Now, an electrode is actually a road through which a current enters and leaves the electrolyte during electrolysis. So we have electrode. I think this is not a new thing to you. We have been seeing this, and this is actually a method which actually allows electrons to flow away or actually enters. Flow away or actually enters. Now we are seeing an electrode that does not influence or alter the products of an electrolysis is called an inert electrode. So we have those electrodes which are inert. Inert means, I think we informed you learn about inert gases. Inert means does not react. So therefore, we have the electrodes which does not react. And therefore, the example there that we have here are, number one, we have platinum. Platinum is another electrode. Then number two, we have carbon graphite. Those are the two inert electrons that we are using, and we will be using in our lessons which are coming. Now we are saying the positive electrodes is called anode. The positive electrode is called anode. The negative electrode is called actually the cathode. But I want us to look at this. The positive electrode is called anode. What is the anode here? Anode is actually the electrode that through which current enter the electrolyte. Current enter the electrolyte. So we have the current entering. Remember, we have current and then we have electrons. Now, if electrons are flowing in this direction, the current will flow on the opposite direction. Okay? So in physics, we are saying if electricity is if electrons are flowing in this direction, then the current should be flowing on the opposite direction. So therefore, if the current enters, that means electrons are leaving. So the anode actually is where electrons leave. Now, the negative electrode is actually called the cathode, and the cathode is actually an electrode through which the current leave the electrolyte, and electrons enters the electrolyte. So it is where electrons are flowing to. And now, during the electrolysis, free ions are attracted to anodes. Free ions are attracted to ions where they lose and or donate electrons to form neutral atoms or molecules. Now, so we have, for example, we have this is M ion, and then it's actually giving us M, not M ion, but M is giving us that plus one electron. So it's actually lose an electron there. It's lose an electron. So whereby we have that one losing an electron. Now let's look at more on this. The neutral atom or the molecule form the product of the electrolysis at the anode. This is called discharge at the anode. It's called discharge at the anode. It's actually called discharge at the anode. Let's look at this. Let's look at more on this. So we are saying during electrolysis, free cations are attracted to the cathode where they gain electrons. Remember, the other one was losing electrons. So they gain electrons here to form actually a metal there. The other one was forming an ion. This one is forming a metal. Now, so if we have here monovalent, then we have a divalent, the same. So we'll have them with respect to that. And then we have the neutral atoms or molecules form the products of electrolysis at the cathode. So we have neutral atoms forming that, but we have in that one we have the ions forming the product. We have the ions forming the product. This is called discharge at the cathode. So let's look at further on this. A compound or a solid mixture containing many ions in an electrolytic cell the discharge of ions in the cell depends on the following factors. So we have factors which affect discharge. Remember, we can be having an electrode, but having two ions which migrate. So which one are you going to which one is going to be discharged? It depends on some factors now. So number one here, we are saying the most electropositive cations require more energy to reduce or actually to gain electrons, and that's not readily discharged. So if we have two cations, and they want to gain electrons, then the one which actually gains electrons is the one which actually has less energy to gain electrons. Now, then the higher the element or the metal in the electrochemical electrochemical series, the less readily. Now, so let's look at this the reactivity series of actually discharge of cations. Now we have here potassium, we have sodium, we have calcium, we have magnesium, aluminum, ions, we have zinc ions, we have two ions, we have lead, then we have hydrogen ions, then we have copper, and then we have here mercury. Now, so we are saying this, the one which actually on the top here are least discharge. If we have a metal here which are actually you are comparing. So if we are comparing, for example, zinc and magnesium, obviously if the two of them migrate to the same electrode, then one of them which is actually lower on this reactivity series will be discharged. So if we have here magnesium and zinc now will be discharged in that discharge. So if for example we have hydrogen ions and we have, for example, zinc, hydrogen ions will be discharged because it actually requires less energy to be discharged. In fact, this one requires around 0.04 volts to be discharged. So therefore, this one actually is preferentially discharged, as that's actually one of the factors now that we have. Now let's look at the second one. Let's look at the second one. Now which are now the anions or the radicals. The hydroxyl ions is the most readily discharged. Note that is the most readily discharged anion. All the other ionic radicals such as sulfide, we have carbonate, we have hydrogen sulfate, we have hydrogen carbonate, and then we have nitrate, and then we have phosphate, are never discharged. So if we have, for example, hydroxyl and we have sulfate, or this sulfide, carbonate, hydrogen sulfate, hydrogen carbonate, nitrate, phosphate, obviously this one will be discharged, and therefore the others are not discharged because they are never discharged. Why? Because all of this requires high energy, requires the highest energy to be discharged. Now, the ease of discharge of halogens ions increase down the group. Ease of discharge increase down the group because now this actually readily can easily do what? Can easily gain electrons, can easily or not gain electrons, not gain but lose electrons. Can easily gain lose electrons. Can easily lose electrons. So we have here can be discharged here easily because now this one, if it is now this an ion, can easily lose electrons. So remember, as you go down here, this actually leads readily or discharge. Now we are saying sulfide carbonates, hydrogen sulfide, hydrogen carbonate, nitrate, phosphate are never discharged. That's what we have said. So when the two or more cations are attracted to a cathode, the ion lower in the electrochemical series is discharged. I hope now you have the electrochemical series. So I hope you have said that instead of that which is higher as per table 1 above. Table 1 above. So we have table 1 and we have table 2. Now this is called preferential discharge at the cathode. Preferential discharge at the cathode. So it's actually discharge at the cathode. Remember, cathode here is actually the negative terminal. So those will require electrons. So when the two or more anions are attracted to anode, the ion higher in the electrochemical series discharge instead of the one which is actually lower as per the table 2 above. So I think you still remember this table here. So the one which is actually higher higher here is now the fluoride ions. So therefore, they are discharged. They are discharged. They are easily discharged. So this is actually called preferentially discharge at the anode. But now we are going to look further. Maybe for us to understand this, we are going to look at the examples. But I want you to note those which we have said. We have those we are calling preferential discharge. We have other factors in that, whereby we have concentration. Concentration also affect. Then we have the type of the electrode. So we have concentration and the type of the electrode as other factors which affect discharge of ions. So therefore, I want you to still go ahead, read ahead of us, and we will come next time. We will look at some examples which is going to give us more understanding on that. So that marks the end of our presentation. Don't forget to subscribe at Mwalimu Institute as you watch our presentation. So may God bless you. Thank you.